Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today. It's called Count Days Without Meetings. I noticed that the acceptance rate is quite low again, so let's see why. So you're given so we have days, which is an int. Yeah, it's just any int, and then we have meetings, which is like a list of lists. Looking at these, I think it's just a list of like 2 items, like for each element. So given that representing the total number of days an employee is available for work, right? You're also given a 2D array meetings of size n, where meetings I, right? So we have a start and end this time. So it might be some interval problems. Represents the starting and ending days of meeting I. So we want to return the count of days when the employee is available for work, but no meetings are scheduled. And the meetings can overlap. So we want to sort it in some ways first, definitely. How do we do that? Yeah. Okay, so it has to be n or n log n, of course. This is a given. And that's like the start and end time. And the start and end time could be on the same could be on the same day. Okay, so we get the question now, but we have some interval problems now. They are like definitely one of my weakest problems. But yeah, I think like we definitely need to sort like either on the starting time or on the ending time. If not, like it'll be way too slow, definitely. So, um, yeah. So let's say for let's just draw out some random intervals. So there are, if we sort it on like based on the ending, well, if we sort based on ending, we can check, we can check whether the start before overlaps with the overlap with um the previous interval. So like let's say if it is here, then that means there are no time like in between, right? But if it is something like this, we have to like find how many days are in between here. What other possibilities are there? Oh yeah, it could be like that as well. Oh, actually, maybe this question isn't too bad. So if we sort it based on the end, um, there are only like really 2 possibilities. Well, the first one is there is a gap between them. We have to find the number of days. The second case is something like this, where the start time is before the end time, or I think if it overlaps as well, it's like the same, I think. Yeah, wait, does it say inclusive? Yeah, so inclusive. So if the start time of the next interval is equal to the end time of the current interval, then yeah, you don't get any time there as well. Okay. So yeah, I think we can start coding. Oh, the other thing we have to worry about is we have to we have to find out. So like let's say you have a bunch of intervals, but like you have like that number of days, right? So you have to like find this and that. But to get that, we can just like get the maximum of the end time and the minimum of the start time, and we can get that. So I think if we do that, we should have no problems. But well, again, the acceptance rate is quite low. So yeah, surely, yeah. Let's code it out now. So meetings, we want to sort based on the end time, right? So lambda x We want to sort based on end time, and then the front is just whatever, right? Wait, let me check that. Yeah, I'm extremely weak in um in intervals, so I want to make sure I get it right. Yeah, so if we are sorting based on end time, um, and we have something like this, so what if we see this before that? It doesn't really matter, right? Because we are only checking like the next start time with the next start time with the like the current end time. So yeah, it should be fine. So we can just do this. I think we have to do like key equals. Surely that's correct. Surely. Yeah. So we have that, and then we also want to uh get min start time and max end time. So um so min start, we'll set it as, well, what is the bound? So if we set it as like 10 to the power of 9 plus 1, it'll definitely be fine, and we're guaranteed that there will be meetings, right? Yeah, we're guaranteed there is at least one meeting, so like it'll get overwritten. So the max end will, we don't need that. We'll set it as -1, and that will also definitely get overwritten. Yeah, so for here will be get number of days in between min start and max end. We're gonna find min start and like the minimum starting point and the maximum ending point during the loop. So that we are basically saving a bit of time there. So we have for start end in meetings. Oh, what is this? Okay, there we go. So min start is going to be equal to the minimum of itself and the current start. Same thing for max end. Except this time we actually want the max. Yeah, so the other thing we have to check is, oh, actually, maybe we want to enumerate it. Maybe. Yeah, honestly, I'm not sure if this works. Does it work like this? I'm actually not sure. Whoa, we can find out new things every day. Yeah, maybe you don't even need the brackets, but let's see if it works first. Let's print these things out. At the end, we can just do a stop. Let's just run this, see what happens. Does this format actually work? Yeah, okay, so maybe you need this. Maybe. Like, will having a bracket work? It would. That's very interesting. I've never done enumerate for like for list of list. So yeah, okay. So that works. That's really good. So let's get back to the actual problem. Well, actually, do we want to look at each pair instead? Yeah, we do have to look at each pair, right? So if I is bigger than 0, so, well, for the first one, wait, I'll just do this. Like, for the first one, there isn't any like endpoints to look from before, right? So we don't. Do you want to do it as pairs? I think that's a bit nicer, right? Yeah, okay. Let's actually separate these out, because like it will basically take kind of the similar amount of time anyways. So we'll do this. So for start end in meetings, so we'll get the minimum start point and the maximum ending point first, and then we want to get unscheduled days in between. So now we can do for I in range, the length of meetings -1, because we are looking at each pair, right? So we are looking at I plus 1 and I. Yeah, so let's see what we have to find out for that. So I think like we can have the number of free days. We set it at 0 first. Yeah, actually we can also add the free days at the beginning and at the end first, from like what we have done here. So number of free days, we want to add the minimum starting point. So if minimum starting point is 1, well, we can just minus 1, which is like the start. Yeah, just do -1. I'm too lazy to write a constant for that. And then also we want to add well, the ending day. So that would be the number of days, right? Minus, well, if the ending date is, if it is the same, then we don't actually get any days. So we can just do minus max end. Yeah, hopefully I'm pretty sure there isn't any off by 1 error here. Yeah, okay. So we have solved the start and the end. Now we should solve in between. So we can do meetings. We want to check the start of that, right? And then we want to compare that with the ending. So so this is going to be meetings I plus 1, 0. This is going to be, I'm not going to write out the whole thing, meetings I and then 1. Yeah, and we want to check this minus that, right? Yeah, so I want this minus that, and we can get like the number of days in between. But then, yeah, actually let's consider the non-overlap case first. So something like this. So we want this minus that. We're gonna get a number, but then we actually have to do a -1 again, because like imagine this is 4 and 5. Like if we subtract like 5, if we like do 5 minus 4, we're gonna get 1, but there isn't actually a day in between, because like we can't actually use like 4 and 5. So we have to do a -1 here. So this is like for if it is not overlapped. If it is overlap, this thing is going to be negative, right? So that means we want to actually get the minimum, not the maximum of these. So if this is negative, it's just going to become 0, and we're not actually like deducting any free days. So num free days, we want to add this, and we just want to return number of free days. Surely that's correct. Hopefully I don't run into any edge cases. Oh no, dang it. What did I do wrong? Okay, let's try. Wait, how many days have I got? Okay, let me print out meetings. So I want to find out. So the output, I outputted 2, but it should be 1. Oh, yeah, my algorithm actually, I think it doesn't work, cause well, we have a 3 and 9 here, right? And that's actually blocking here. So like my algorithm would see that there's a 4 here and we can add that, but that's actually not the case. How do we solve that? Well, another way we can do is like we can add these into like actually I was thinking of adding it into a heap, but it wouldn't work. Yeah, how do we go with this then? There's also another 3 here. Wait, what if we filter what if we filter the ones that are what am I gonna say? The ones that are like completely inclusive into like one of the next ones. Yeah, I think we will have to do that. So how do you want to filter it though? So when we get to 3 and 9, we can see that 8 and 9 is completely like it's completely inside this interval, right? So we want to remove that. And then when we look at 5, 8, well, again, we have the same thing, right? So like this is completely covering this, so we can remove that. And then like, so would a stack work? I think a stack would work. But then we have to sort this in a better way for sure. Then we can just do this. Wait, how do I want to sort it though, actually? What if we do sort it like this? What do we get? Wait, lambda was never closed. Oops. Yeah, so now we get this. And well, right now, if the current so let's say we have like 3 and 9, and then when we are trying to add 8 and 9 in, we can see that it wouldn't work, right? Because like this thing is completely like contained. Wait, but then it can go backwards as well. So do we actually want to sort it the other way? Yeah, we want like both the checks to be going one way, right? So when we are trying to add 3 and 9, we can see that this is completely this includes that. So we can remove that. This includes that, and then we can remove this thing. It doesn't include that anymore. So yeah, that should be fine. And then when we add this, that's fine. This is also fine, that's fine. But then when we get to this, we want to remove this thing, right? And then when we get to this, we want to remove this. And then when we get to like 313, we are actually removing a lot of stuff. So we are only going to get 1, 3, and 313 at the end, which would give us 1 at the end. Yeah, so I think we actually have to use a stack here. That's very interesting. Filter meetings. So we want to do a stack. I guess like for the first, we can do like, for start and in meetings. So we want to filter out, I would just call it useless intervals. So for start and end in meetings, so if filter meetings, well, actually I should do while filter meetings. So while there are some stuff in the stack, and the current starts we should write a function for this. So complete overlap. So we have start1, end1, start2, end2. We should return a boolean. So return s1 is smaller or equal to s2, and e1 is bigger or equal to e2. And here we can just do complete overlap. So if the current start and end completely overlap whatever is in filtered meetings, so the last thing, and then we want to get this, and then and then we just copy this, do that here. So that's how we check. So if that's the case, we want to pop. So pop, and then at the end we are going to add our current item into the stack. So here, instead of doing so instead of doing like the original meetings, we'll look at the filtered meetings instead. Yeah, here are all of these. We have to change it to filtered meetings, and I hope it works. And I hope there aren't any more edge cases. I definitely need to get better in interval questions. I'm really bad at these. But yeah, hopefully you get a bit more interval questions so I can get better at these as well. But yeah, thanks for watching. If you have any questions, make sure to comment below, and I'll try to answer them as much as possible. So yeah, see you tomorrow. Bye.